Hello there, I'm Kyle Lightfight. I'm here from the Goodyear Tire and Rubber Company to tell you a little bit about my career in mechanical engineering. A little bit about me, my background. I am a product of Southeast High School in Portage County and the University of Akron. Currently at Goodyear, I'm a tread and cavity engineer. I'll talk a little bit more about what that entails later. So a little bit about mechanical engineering. It is a STEM profession. It's science, technology, engineering, and mathematics. Engineering, STEM. This is a little bit tongue-in-cheek about engineering, but it actually turns out to be very true. An engineer is a person who solves problems you did not know you had using methods you do not understand. An engineer is also a person that has forgotten more about math than most people will ever know. To speak a little bit less tongue-in-cheek, engineering is using science and mathematics to make the world around you adapt to what you need. A little bit more about engineering disciplines. Major disciplines, you have mechanical, electrical, chemical, industrial, civil engineerings, and then there's different specializations within those. And then in the right-hand side of the screen here, you can see that there are the top 10 best salaries within engineering. A little bit about the mechanical engineering education. Years 1 and 2 are more your engineering foundation classes. They're your calculus, differential equations, chemistry, physics. You probably have exposure to some of those in high school. They tend to go quite a bit more in depth in college. Years 3 and 4 are more your engineering theory and co-op programs. So your engineering theory is like machine dynamics, thermodynamics, where you learn a lot about how energy works, fluid mechanics, water, air, and then you're also doing your co-ops, so you're gaining some work experience within that. Year 5 is your engineering application and more co-oping. Engineering application is you're doing real world projects. You're solving real problems within a classroom environment. Then you're also doing laboratory studies to kind of apply the theory that you learned earlier on. So a little bit more about what you can do with a mechanical engineering degree after you graduate. Say you choose not to go into the industry and work as an engineer, you can, there's numerous graduate degrees, master's degrees, doctoral degrees within engineering. There's also law school, medical school. You can go into management with an MBA. Certain companies prefer a master's in engineering management, which is essentially an MBA, but it's a little bit more technically focused. So within engineering careers in the industry, you have 3 main branches that you can go into. There's product, which is your product design. So for me, I'm part of product design right now, where you're designing a product that's going to go out to consumers. There's also the process. It's how those products are made, and that's quite a bit different from product design, but there's a lot of elements that they share. I've had quite a bit of experience within the process engineering side as well. I'll talk a little bit more about that when I get specifically to my career. And then there's also the project side, where you're using the critical thinking and logic elements that you learned mostly subconsciously through your engineering schooling, and you're applying those to being able to solve problems within a project sort of view. So product, again, product engineering, product design, that's how we went from the tire on the left-hand side of the screen to the tire on the right-hand side of the screen. Took 60 or so years, but that's what it is. It's constantly improving what you already have to put something better out to consumers. And then process engineering. On the left-hand side, you have a gentleman building a tire circa the 1920s. Very, very manual, very, very hard labor. And then on the left-hand side of the screen now, you have a more modern tire building machine. And yes, that's a product, but there's a process within that product that also had to be designed and had to be very, very well thought out. Logic, critical thinking, things like that. Those were very important in designing that so that it became a safe machine that built what was needed. And then project-wise, especially within Goodyear, plant startups, plant design, those are huge, huge projects. Many, many engineers are working on them. And it takes all of that to make that project come together. People within other disciplines absolutely help and can run these projects, but engineers have a specific skill set that allows us to think through things logically and make sure that processes are followed so that the project ends up being successful. So me personally, why am I an engineer? I grew up in machine shops. My father worked in machine shops his whole life. My uncle owned a machine shop. My grandfather owned a machine shop, different machine shops. So I was always around them. I was able to go into work with them. Loved seeing the machines run. Loved trying to understand how they worked, even from a very young age. So that really was a driver for me to get into engineering. Also, like a lot of people that have interest in engineering, I was really into Legos, Connects, building things as a kid. My grandfather had a wood shop in his garage, and he would essentially turn me loose and let me try and build things. I had an awful lot of fun with that. Tore stuff up, put it back together, figured out why it worked, how it worked. I really enjoyed it, still do to this day. Final reason why, always loved critical thinking, problem solving, puzzles all through school. Yes, math, physics, science, those things were great, but really at the root of it, I loved solving problems, and that's what engineering is about. It's using math and science to solve problems. A little bit about my career. From 2013 to 2014, I was a co-op, which is what you call an intern in engineering. So I was a co-op with the quality department. 2015, I was a co-op on the process engineering team. And then 2016 through 2018, I was a full-time process engineer. And then from 2018 until the present, I have been with the tread and cavity team on the product development side. A little bit about my quality co-op. It was a very broad, overarching project. That's why I was there for over a year. It involved the stamping on the sides of tires. And you can see here on the left-hand side of the screen, you can see the stamping for the DOT code, the date code, things like that. And my main project on that team was designing a method to make sure that those codes and things were correct on the tire, because if they're not, it can lead to some pretty serious consequences from regulatory bodies. And then the other thing that I worked on over here on the right-hand side of the screen, mirroring, on the right-hand side of the screen is a tire curing bladder. So I worked pretty heavily on a project to understand the curing bladder process, the ordering process, design process, and how they get to our plants, to make sure that our tire plants always have the right curing bladders to be able to cure the tires that they need to get to consumers. And just to back up a little bit, a tire goes into a mold, and then this curing bladder here goes up inside the tire, and then it inflates, and it pushes the tire into the mold, which gives the tire its final shape. It's very important to making sure the tire is robust and will do the job we say it will do. On to my process engineering co-op. I worked in the mixing team, which it's the very first part of a tire plant. Rubber comes in, it's raw, it doesn't have the things that it needs in it, so it needs to be mixed. So starting over here on the left-hand side, I worked on slab feeder cutters, and what they are is rubber comes in big wide slabs, 3 feet long, and it needs to be weighed very, very precisely. And to do that, it needs to be cut just in order to hit the right weight. And these cutters, they're very finicky machines. Rubber has some very, very hard particles in it, especially silica rubber, which is typically used in tread. Silica is near diamond hardness, so that causes a lot of wear on metals. So I had a project to help redesign these machines so that they last a lot longer. They wear out very quickly in our plants. I also worked on making sure we had replacement mixer bodies ordered. Again, because rubber contains some very hard materials, mixers tend to wear out. So I was in charge of requisitioning over $30 million worth of mixing equipment just in my 6-month co-op on that team. I also worked on a safe method to handle tread rubber. Tread rubber in and of itself is not dangerous or volatile, but it sticks together and it can take very, very high forces to separate it, which can cause some injuries. So I helped develop a manipulator to allow people in the mixing department to separate these pieces of tread rubber so they could go back into the mixer. And then finally, I worked on some mixing gearboxes, different gearbox technologies, really just exploring possible new ways that we can transfer power from our mixer motors to our mixers. Then in 2015, I was in our Danville plant in Virginia as a co-op, and that was probably the most valuable experience I've ever had. They set me with a maintenance person, and I essentially followed them around and helped them with maintenance tasks. And while that may not sound like the most exciting thing, in a manufacturing environment, that is incredibly fun, because things break down and you have to get them fixed, and sometimes you can't always do the most elegant solution. You have to make things work, but you have to also make sure that they're very, very safe. So it was constantly being busy working on things. And then what that contributed to my career when I got back to Akron and started working on machines again is you have these maintenance tasks in your mind, and you have to remember how your design can affect the maintenance of the machine. Whether you design a machine that breaks down often enough that maintenance is a pain, or you build a machine that is very good but maintenance maybe can't do the work they need to do. So it teaches you a lot about what you need to consider as you're designing a machine. So my first career at Goodyear as a full-time associate was in the component prep process engineering team. I spent time in 8 countries on 3 continents, and I think I was in upwards of 13 or 14 manufacturing plants, both for Goodyear's and for some of our suppliers, to understand these machines, to install these machines, and then to make sure that they were running the way that they were supposed to. My main responsibilities were bead apexing and bead winding, and I was pretty much using logic, science, so chemistry, physics, math, to make sure that these machines, number one, were capable of what we need them to be capable of, but number two, would fit into our factory footprint and be safe enough for our associates to use. I had the chance to use quite a bit of 3D printing in order to make parts more cheaply and more quickly than through some other manufacturing methods. So it was a really good experience for me. Currently at Goodyear, I am a tread and cavity engineer within the product development team. I work on the final molded shape of the tire, whether that's the tread pattern or this cavity shape here. They both have an extreme influence on the performance of the tire. So in my design work, what I do is there is an initial design that I come up with, whether it's an old tire that is a good starting point or something that's suggested from elsewhere. We start there. I do my design that I need to do, and then I run finite element analysis, which is kind of what you're getting a flavor of down here with this little tire footprint. And that helps me understand how that tire will perform. So then I take that data that I get from that finite element analysis and I plug it back into the design, and I make some changes to steer that data more towards what the target that we're looking for. I work quite a bit with our chemical engineers for our compounding team. They design the rubber, they say what's going to go into the rubber so that it has the performance that we need. I work with our construction engineers who tell us the other components that are going into the tire. I work with marketing to make sure that our performances are going to hit what they're hoping that we can hit and what they're telling customers that we can hit, so that we can continue to sell tires and have business. Also, something that gets overlooked very often is the impact of engineering on your daily life. I use it all the time, whether it's really consciously, hey, I'm gonna use my engineering knowledge for this, or whether it's a subconscious thing. So a little bit about me, hobbies wise, I love to play guitar. I train for powerlifting, and I love to do my own work, or my wife and I's own work around the house. We really enjoy doing things on our own. Guitar wise, I have the disadvantage of being left-handed, so it's very hard to find left-handed guitars. My frustration with that hit a peak, and I said, you know what? Okay, I'll build my own guitar. So I used a lot of my engineering knowledge, mathematics, things like that, to build this guitar and then to troubleshoot the electronics. I'm not an electrical engineer, but I was able to use logic and deduction skills from engineering to be able to troubleshoot and get this thing working. Also, love to train for powerlifting. To buy a powerlifting sled is between $50 and $400. This tire sled that I was able to design and build was $20. Took a little bit of work and some thinking and some planning, but it was very important that I was able to do this myself. You know, you save money, yeah, that's great, but there's also the sense of pride in doing things yourself. Also, down in this bottom corner here, this is a patio paver project my wife and I just finished up, and I used a lot of the project engineering knowledge that I'd had to help plan this out so that we could get it done. And I think that all told, we ended up saving ourselves roughly $2,000+ by doing this ourselves versus having somebody else do it. So being able to think things out, plan things out, being able to understand, you know, physics, chemistry, math, and how they apply to your daily life is very, very important. It can really make things easier and give you capabilities that maybe you wouldn't have had otherwise. Can other people from other disciplines do this? Absolutely. People do it all the time. But it helps me specifically, and I know it has helped other people to do the same thing and start doing more things for themselves. Why do I love engineering? The flexibility. My first career at Goodyear full-time, process engineering, it involved a lot of travel. I wasn't able to be home as much as I wanted to be, but I wanted to stay with Goodyear because I truly do believe in the company. So I was able to find another job within Goodyear that is very, very different and a totally different experience. It feels like a new job at a different company. But I was able to stay with Goodyear. You know, it's always nice to get to keep your benefits, things like that, but it's the continuity of the company and understanding it. So I was able to parlay that into a different job and stay where I am, which is great. If you guys have any more questions or anything, this is my contact info, and I will be sending out this PowerPoint after I make this video so that you guys can follow along. If you have any questions, feel free to email me at this email, and I'll do my best to get back to you. Thank you guys very much for your time, and everybody take care.